Hi everyone, welcome to My Max Academy. In this video, we'll continue with the chapter Continuity and Differentiability, which is chapter number 5 from your 12th standard CBSE Mathematics. We will start with the definition of continuity of a function in page number 150 in your textbook. Page number 150, definition 2 in page number 150. That is, when do we say a function is continuous? So till last video we had seen when do we say f is continuous at a particular point. Now here we need to understand, or we will learn, when do we say a function is continuous. So that is continuity of a function. It's not at a particular point. When do we say the function as such is continuous? So that is, a function f is said to be continuous function. A function f is said to be a continuous function if it is continuous at every point in the domain of f. If it is continuous at every point in the domain of f, which means a function f is said to be continuous if it is continuous at every point in the domain of f. If f is continuous at every point in the domain of f, then we call f as continuous. Suppose if f is not continuous even at one of the points in the domain of f, even if it fails for one point, then we'll say the function f as such is not continuous. So for f to be continuous, it has to be continuous at every point in the domain of f. For f to be not continuous, even if f is not continuous or discontinuous at one of the points in the domain of f, then we'll say f is not continuous. Even if it fails for one point, even at one point if f is not continuous, then we will say as a whole f is not a continuous function, and f becomes as a whole continuous function if it is continuous at each and every point in the domain of f. So based on this definition, we will solve some of the problems. I'll start with example 7 in page number 151 of your textbook, which is example 7. EG means example. Example 7, what it says is, what is given? The given function is f of x is equal to mod of x. F of x is mod of x, and what we need to check is f continuous. We are not checking at a particular point whether f is continuous at a particular point, like what we had done in the previous video, in my previous video. Here f as such as a whole, can we say that f is continuous? And as per the definition of continuity of the function, we can say f is continuous if f is continuous at every point in the domain of f. Here the domain is set of all real numbers, which means we should check whether f is continuous at each and every real number. F is continuous at each and every real number. If so, we can say f is continuous even if it fails for one real number. If f is not continuous at a point, at one point, or one real number, point or real number both mean the same, then we'll say f is not continuous. So for that solution, solution is, let's write f of x. F of x is mod x. First thing is, we need to write the definition of mod x. We'll have to rewrite the definition of mod x. So what is the definition of mod x? We know the definition of mod x is x when x is greater than or equal to 0. It is minus x when x is less than 0. This is the definition of mod x. So first of all, we should write a function without the mod. So f of x is mod x can be written as f of x is this. F of x is x when x is greater than or equal to 0. It is minus x when x is less than 0. This is the definition of mod of x function, which you would have studied in your 11th standard also. So now we need to check whether f is continuous. So which means we have to take all the points or all the real numbers, and we should check whether f is continuous at each and every real number. Right? So for that, we'll say let a be any real number. We are taking any real number, which means a is a point in the domain of f. Let a be any real number. Now we must check whether f is continuous at a. Here a is any real number. Now again, when a is any real number and we need to check for every real number, then we must try to split the entire real number into different intervals based on the definition of f of x. See, our real number r is what? Your r is, so a belongs to r, which means your r is minus infinity to infinity. Open interval minus infinity to infinity is set of all, this denotes set of all real numbers. And a is a number from, a is a real number, which means a is coming from this open interval minus infinity to infinity, which is your set of all real numbers. Now we have to break this into different intervals based on the definition of f of x. So which means we have to have different cases. So first case what we will have is, we will make this as, say your minus infinity to infinity, which is our real number r. We will make this as different intervals, and we need to check in each interval if f is continuous. If in each interval f is continuous, then we can say this f is continuous in the entire r. So this we can break it as minus infinity to open 0, which means I am taking all the negative numbers first. Why we are taking all the negative numbers? Because for all the negative, when x is less than 0, f of x is minus x. So this is one case. So if you prove that f is continuous in this interval, then we will prove for all the negative real numbers. Then we should prove for this union, in the union of our set, then singleton 0, only 0. Then union 0 to infinity. So what we are doing here, the entire real numbers minus infinity to infinity, we have broken into minus infinity to 0, then only 0, then 0 to infinity. So here it covers all the negative numbers, here it covers all the positive numbers, and 0 alone we have to check it separately for the continuity. Why? Because at the point 0, the function definition is changing. So whenever the function definition is changing at a particular point or at set of points, so those points we have to check the continuity separately. So this is from minus infinity to 0. Open interval means 0 is not in this set. Then only 0, again 0 to infinity open interval, which means 0 is not here also. Which means this denotes set of all positive real numbers, this denotes set of all negative real numbers, and this is 0. Then the combination of all the three will give you set of all real numbers. Now we need to check whether f is continuous here, here, and here. If it is continuous at each of these sets, then f is continuous. Now we'll take the first one. So case 1. Case 1, we will say let this a belongs to this interval minus infinity to 0. A is coming from this interval minus infinity to 0, which means a is negative. And a belongs to this means a is negative. Now we need to check. We need to check the continuity. So we need to check if limit x goes to a, f of x equal to f of a. This is the definition for continuity of a function at a particular point, right? So a is any point, but a is negative. Why? Because a is coming from here. So we are taking a negative number, any negative number, and if you prove that it is true for any negative number, then it is true for every negative number, right? So here we are not taking any particular value for a. A is any real number, but a comes from this set, which means a is a negative real number. So we need to check what is the value of limit x goes to f of x, whether it is equal to f of a. Let's find f of a. What is f of a? So we are doing case 1 first. So case 1, so for that f of a is f of a. Now what is the value of f of a? A is what? A is negative, because a belongs to minus infinity to 0. The meaning of this is what? The meaning of this is minus infinity less than a less than 0, which means your a is between minus infinity to 0. That's the meaning of this. Now a is a negative number, right? So when a is negative, what is f of a? F of a will be equal to what? So x is a, your x is a, and a is negative. A is negative means what? X is less than 0. F of a we have to find. Your x is a, I have put x equal to a. When x is negative, which means a, your x is a and a is negative. When a is negative, f of x is minus x. So this will become minus a. What is the value of f of a? F of a will be minus a, because your a is negative. When your a is negative, your f of x is, or when your x is negative, your f of x is minus x. So your f of a will be minus a. For all the negative numbers, we will use this function. And a is a negative number, because a belongs to this interval. Now what is limit x goes to a f of x. So here we need not go for left hand limit and right hand limit. We need not go for left hand limit and right hand limit because your a belongs to this interval, negative numbers, and negative numbers we know what is the definition of f of x is minus x. For all negative numbers we are going to use only this function because your a is coming from this. So we don't have to go for left hand limit and right hand limit because we know that a is negative. For all the negative numbers our f of x is what? Minus x. So here itself we can write when a belongs to this, our definition of f of x is what? Our f of x is minus x. Our f of x is minus x because your a is negative. So this is the definition of f of x. Limit x goes to f of x is what? F of x is minus x because a is negative. So you'll get limit x goes to a minus x. Now we'll substitute f of x is minus x. Why f of x is minus x? Because a is negative. For all the negative values f of x is minus x. So now we have to substitute. In the place of x we should put a. So this will become minus a. So what we have got? We have got f of a is also minus a. Limit x goes to f of x is also minus a. Therefore we'll say limit x goes to a f of x equal to f of a, and both are equal to minus a. Right? F of a is also minus a. Limit x goes to f of x is also minus a. So therefore we'll say f is continuous for every a that belongs to minus infinity to 0. F is continuous for every a, which means f is continuous for every negative real number because a is a real number. A is a negative real number. So we have proved that f is continuous for all the negatives. So in this we have proved that f is continuous. Now we should prove at this point 0, but before we go to this, we'll do this in the end. We'll do this as case 3, we'll do this first. Second case is, so case 2. Case 2 will take this interval. Let a belongs to 0 to infinity. Let a belongs to 0 to infinity. So what is the meaning of this? Which means your 0 is less than a less than infinity. That is the meaning of this. Which means a is a positive real number. Now we need to check this. Same thing we need to write. So what is our f of x? Our f of x will be what? Equal to x. Why? Because a is positive. We are going to check for the continuity in this interval for all positive values of x. 0 to infinity. For all positive values of x, our f of x is what? X. Whenever x is greater than or equal to 0. Greater than or equal to 0 means here it is greater than 0. For all x greater than 0, it is x. So we'll say f of x is x. That is the definition in this interval. Definition of f of x in this interval is f of x is x. So now we need to check. We need to check if limit x goes to a, f of x equal to f of a. If you prove this, then we can say f is continuous for every a belonging to 0 to infinity, which means f will become continuous for every positive real numbers. Now let's substitute. Now let's find what is f of a. What is f of a? F of x is x. So f of a is a. F of x is x means f of a is a. Now let's find what is limit. So we found this. Let's find this. Limit x goes to a, f of x. That will be equal to limit x goes to a, f of x. F of x is what? F of x is x. So x. Now wherever x is there, now we are going to substitute the limit. In the place of x, I'll substitute the limit a. So in the place of x, I'm putting a. So this x will become a. So limit x goes to f of x is also a, and f of a is also a. So both are equal, which means you have proved these two are equal because this value is this, which is a. This value f of a is also a. Therefore both are equal to a. Therefore both match. So therefore we will say limit x goes to a, f of x. Therefore limit x goes to a, f of x equal to f of a. Both are equal to a. Therefore f is continuous for every real number a belonging to 0 to infinity. For every real number a belonging to, or we can say for every a A real number is also fine, or a belongs to 0, infinity means it's a real number. So for every a belonging to 0 to infinity, which means for every positive real numbers, f is continuous. So we have proved that f is continuous for all negative numbers, negative real numbers, and f is continuous for every positive real numbers. Now the only thing that is left out is for 0 we have to check. At the point 0, so 0 should be treated separately. Why? Because at the point of 0, the definition of the function is changing. It is x when x is greater than or equal to 0, minus x when x is less than 0. So that has to be dealt as a separate case, only for that one particular point. Here we have group of points, all negative numbers. Here all positive real numbers. So that's why we did not put a particular value for a, because here a denotes set of all positive real numbers. Here a denotes set of all negative real numbers. Now we need to check for at the point x is equal to a. Now case 3. Case 3 is let a equal to 0. At the point a equal to 0 we are going. Now we know the value of a. A is 0. So we took for a minus infinity to 0 open, then 0 to infinity open, then at the point 0, this one. So this was case 1, this is case 2, this is case 3. Case 3 is a is equal to 0. At the point 0 we have to check whether f is continuous or not. So which means we need to check if limit x goes to 0, because we know a is 0 here. We generally put limit x goes to a, but we know a is 0, so I can put a particular, I can put 0 here instead of a. But here we did not know. Here a was not a particular value, it was a group of values. So we couldn't substitute a particular value for a here. But here we know that a is 0, so we are putting a as 0. Your f of x will be equal to f of 0. So limit x goes to 0, f of x equal to f of 0. This is what we have to check. To check if f is continuous at 0 or not. Fine. So I'll erase this. Now again, let's find what is f of 0. Let's find what is f of 0. What is f of 0? F of 0 is, as per the definition, when x is 0, is f of x is x. When x is 0, f of x is x, so f of 0 is 0. Now we should find limit x goes to 0 f of x. Right? So we need to find limit x goes to 0 f of x. Now to find limit x goes to 0 f of x, we must go for left hand limit and right hand limit. Why we are going for left hand limit and right hand limit now? Because the value of the function is getting split into two definitions. At what point? At the point 0, and we are finding the limit at the point 0. So whenever we are trying to find the limit at the point where the f is getting split into two definitions based on the value of x, we must find left hand limit and right hand limit. Here in these two cases that was not the scenario. That was not the case. So your f of x was always minus x and your f of x is x. For all positive value it is x, and for all negative value it is minus x. And at the point 0 it is getting split. We know the definition at the point 0, it is x. But at that point the function definition is changing at the point x equal to 0, and at that point x equal to 0 only we have to find the limit. So when we are finding the limit at the point where the function's definition is changing, we must go for left hand limit and right hand limit. So let's find left hand limit. So LHL. LHL is what? LHL is limit x goes to 0 minus. Right? If you want to find the left hand limit, right? F of x. That is equal to limit x goes to 0 minus. 0 minus means we are finding left hand limit, which means x is approaching 0 through the value less than 0 from the left side of 0. Right? We have this real number. This is 0 means we are approaching. The x is approaching 0 from the left side, from this side. It is approaching 0 in this side. So left hand limit, which means now f of x. We need to define what f of x we should put. Whether we will put x or minus x. Here x is approaching 0 through the value less than 0. Through the value less than 0, which means we will try to take one x which is very close to 0 but less than 0. So what could be that x? That x will be, say here if I take any point very close to 0, this x will be something like minus 0.01. So this value is very close to 0 but less than 0 because it is minus 0.01. Now so there are infinitely many values which are very close to 0 but less than 0, but I'm just taking one of the points. Now this point, which is minus 0.01, now we should check this point falls under which category? Is it greater than or equal to 0 or less than 0? It is less than 0 because x is minus 0.01. X is negative. Negative means it falls under this category. At this category, your f of x is what? Minus x. So here we should put minus x. Because your x is approaching 0 through the left side of 0. Which means here it is all negative. Your x is negative. When your x is negative, our f of x is minus x. Now we should substitute the limit. Now in the place of x, put 0. So you get minus 0, which is 0. So our left hand limit is what? 0. Now we must find right hand limit, RHL. What is RHL? That is limit x goes to 0, 0 plus f of x. Left hand limit means 0 minus, right hand limit means 0 plus. So that is equal to limit x goes to 0 plus. Now f of x. Now which function will substitute, whether x or minus x? To decide whether I have to put f of x as x or f of x as minus x, we must check what is the value of x. Which means x is approaching 0 through the value greater than 0, positive. Or from the right side of 0, which means x is approaching 0 like this direction. Now if you take any point on the right side of 0, what will be that x? That x will be something like plus 0.01. Plus 0.01. Now when x is plus 0.01, and if I take a point very close to 0 on the right side of 0, plus 0 means on the right side of 0, minus 0 means left side of 0. On the right side of 0, if I take any point which is very close to 0 on the right side of 0, that will be 0.01. So your x is 0.01 plus 0.01. When your x is plus 0.01, then what will be our f of x? Our f of x is what? X is positive. X is plus 0.01 here. So x is positive, I should use the function x. Your f of x will become x. So therefore it is x. F of x is x. Now we'll substitute the limit 0. So it will become 0. In the place of x, we should put 0. So we'll put 0. So your right hand limit becomes 0. I'm just erasing this part around. I couldn't fit it in the single board, but please, I just erased only the question. So therefore, we'll say therefore LHL is equal to RHL. The limit, left hand limit is also 0, right hand limit is also 0, therefore limit is 0. Therefore we can say limit x goes to 0, f of x is 0. Now what we have got? We got f of 0 is also 0, limit x goes to 0, f of x is also 0, therefore these two are matching, which means this condition is satisfied. Limit x goes to 0, so that's what, see, we found this f of 0, we got 0. Then to find this, we had to find left hand limit and right hand limit, and both of them matched. So we said limit exists, and that is equal to 0. So we have proved f of 0 is also 0, limit x goes to 0, f of x is also 0. So therefore, I am erasing this also. Therefore we can say limit x goes to 0, f of x equal to f of 0, and both are equal to 0. Therefore f is continuous at x equal to 0 also, or we can say a equal to 0, doesn't matter. See, you can interchange a and x, we can also put a equal to 0. So f is continuous at a equal to 0. So we proved in the case 3 also it is continuous. So in the case 1 also f is continuous for every negative real number. Case 2 f is continuous for every positive real number. Case 3 at 0 also, so we had to do this separately for the point 0, because at that point the definition of f of x is changing. So f is continuous at this case 3 also, where a is 0. So which means it is continuous here, it is continuous here, case 2 it is continuous at case 3 here also. So therefore f is continuous at every real number. So therefore conclusion is therefore the question was, is f continuous function? Therefore f is a continuous function, because f is continuous at every real number, right? Therefore f is a continuous function. This is the end of it. Clear? Because f is continuous for all negative numbers, f is continuous for all positive numbers, and f is continuous for 0 also, which means F is continuous function because F is continuous at every point. So you call F as continuous. Fine. Since F is continuous at every number, every real number, therefore we say F is continuous. F is continuous means F is a continuous function means F is continuous at every real number. Fine. So all of you can pause the video and take the notes. I will go to the next problem, which is example 8. Example 8. Now what we should to discuss the continuity of the function f. So f of x is given as example 8 given as f of x equal to x cube plus x square minus 1. F of x is x cube plus x square minus 1. We have to discuss the continuity of this function. Discuss the continuity of the function means we have to check whether f is continuous or not. So to check is f continuous? Not at a particular point. Generally, is f continuous means we have to check whether f is continuous at every real number. Now, solution. Now we'll take any general point. Let a be any real number. Let a be any real number. A be any real number. Now a is any real number. Now here we need not go for cases like what we had here because f of x was just one single definition and there is no mod x or anything. F of x is just x cube plus x square minus 1, single definition. So we don't have to go for cases like what we had done here, the previous problem. Here we had to go for cases because our f of x value changes based on the value of x. F of x, for mod x it was f of x was x when x was greater or equal to 0 and minus is when x was less than 0 in the previous example. Now here it is one straightforward definition, so we don't have to have any cases. We will take let a be any real number because for any real number this is a definition. But here the definition changes. When x is positive, it is f of x is x. When x is negative, f of x is minus x. But here that is not the case. So let a be any real number. Now we need to check. We need to check if limit x goes to a. Sorry. We need to check if limit x goes to a, f of x equal to f of a. If you show that both are equal, then we can say f is continuous at every real number. So then we will say f is continuous. Now let's find what is f of a. What is f of a? F of x is this. So f of a will be a cube plus a square minus 1. This is your f of a. Here we can't put any particular value for a because we have to prove for is f is continuous, not at a particular point. F is continuous means we have to take a be any real number. We can't assign a particular value for it. Right? A is any real number. We got f of a as this. Now what is our limit x goes to a f of x? So we must find that. So limit x goes to a f of x we have to find. Which is this. That is equal to limit x goes to a f of x. F of x is what? F of x is x cube plus x square minus 1. So x cube plus x square minus 1. Now in the place of x we need to substitute the limit. Now it is the time to substitute the limit. Let's substitute the limit. If we substitute the limit, what do we get? We get limit. If we substitute the limit will go. So a will become a cube. In the place of x I am putting a. So a square minus 1. So your limit x goes to a. F of x is what? A cube plus a square minus 1. So now both are matching. Your f of a is also a cube plus a square minus 1. Limit x goes to f of x also a cube plus a square minus 1. So therefore we can say limit x goes to a, your f of x is equal to f of a, and both are equal to a cube plus a square minus 1. Both the values are same and both are equal to this. So therefore we can say therefore f is continuous for every real number. Or we can say f is continuous at every real number. So when f is continuous at every real number, then we call f is continuous. So therefore we'll say f is a continuous function. Therefore we call f is a continuous function. So that is the end of example 8. Right? Or if you can pause the video and take the notes. Now we shall go to example 9. Now what is example 9? Our f of x is defined as 1 by x. What is the, so given is f of x is equal to 1 by x, and obviously x is not equal to 0, because at 0 the function is not defined. F of x is 1 by x, where x is not equal to 0, because when x is 0 this function is not defined. So therefore what is the domain of this? Domain of f is set of all non-zero real numbers. Your domain of f in this problem is, domain when x is not equal to 0 means they are saying domain of f will be r minus singleton 0, all real numbers except 0. That is the domain of f. Now we have to discuss the continuity of the function. We have to discuss the continuity of the function, which means we need to check whether this f is continuous at every point in the domain of f. Which means you have to check whether f is continuous at every point except 0, because 0 is not in the domain of f. Domain of f does not have 0. It is set of all real numbers minus 0. That is the domain of f. Now to check or to discuss, to check is f is continuous. Continuous means continuous function. That is the question. That's what we have to discuss. Right? Now again solution. So what do we say? We'll again take, since we are not checking the continuity at a particular point, we have to take in general, let a be any real number. We can't take a particular value for a. So let a be any real number, or we'll say other than 0. We should say let a be any real number except 0, because it is not equal to 0. Or we can say let a be any point mean number in the domain of f. In the domain of f. Let a be any point in the domain of f, which means a is any real number except 0. A cannot be 0, because a is not in the domain of f. Only in the domain of f we have to check whether f is continuous. Only at each and every point in the domain of f we have to check if f is continuous. If so, then we will say f is continuous. F is continuous means f is continuous at every point in the domain of f. Let a be any point in the domain of f, which means let a be any real number in the domain of f means a is any real number except 0. Now we need to check. If limit x goes to 0, f of x equal to limit x goes to a, f of x equal to f of a. Limit x goes to a, we need to check this. Limit x goes to a, f of x equal to f of a. If so, it is continuous. If not, it is not continuous. Now let's find what is f of a. What is f of a? What is f of x? F of x is 1 by x. When f of x is 1 by x, your f of a will be 1 by a. And it is defined because a is not equal to 0. A is in the point and a is not equal to 0. Obviously, a is from the domain of f. So this is defined because a is not equal to 0. So 1 by a exists. So that is 1 by a. F of a is 1 by a. Now limit x goes to a, f of x we have to find. So this side. That is equal to limit. Here we don't have to go for left hand limit or right hand limit, because f of x is just only one definition. F of x is 1 by x. The f of x doesn't change based on the value of x. Right? So we'll directly go for limit. Limit x goes to a, f of x. What is f of x? F of x is 1 by x. 1 by x. Now we'll substitute. In the place of x, we'll substitute a. Now limit x goes to a, limit x goes to a, 1 by x means it is 1 by a. In the place of x, we have to put a. So it has become 1 by a. So f of a is also 1 by a, limit x goes to a, f of x is also 1 by a. So therefore we can say, and write this here, So therefore, what we have got is, we have got limit, therefore limit x goes to a, f of x equal to f of a, and both are equal to 1 by a. Therefore, f is continuous at every point A, in the domain of f. So we say f is continuous. So in general, we will say f is continuous. The function f is continuous. That's it. F is continuous because it is continuous at every point in the domain of f. The moment f is continuous at every point in the domain of f, then we call f as a continuous function, or we will say f is continuous. Right? So this is the end of example 9. All of you can pause the video and take the notes. I will stop the session here. You can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.